Good morning and welcome to our July Learning Series seminar. My name is Wayne Wilk, Automation Specialist with the Reynolds Company in New Orleans, and I'm just going to introduce the topic real quick. Today will be intelligent power update is our focus. So as we usually do, like to talk about what's coming up on the schedule. Also a little bit of what we just recently have done. The last couple of months are in gray. Like I mentioned a few moments ago, all of our sessions that are online are recorded and are made available on the Reynolds Company's YouTube channel. So we invite you to always go back and watch one of those sessions if you weren't able to attend. Our learning series is what's going on today. That's usually our hour-long session, usually focused on Rockwell solutions. Today, again, is intelligent power update. Coming up next month will be a plant PAX update in the new 5015 Flex HA5000 IO, which is a mouthful to say. Then we'll do a Factory Talk software update. We haven't done that in quite some time. And then finally in October, it's time to preview Automation Fair. And then our tech talks are usually shorter sessions, typically half an hour, sometimes a little bit longer. And this year we've been focusing on our Encompass partners, or technology partners, as they're called. So the partners that are involved in bringing together the full solution with Rockwell. So this month, on the 26th, we'll have Hardy Process Solutions talking about the process weighing. We don't quite have the topics identified for August and September yet. That'll happen very soon. And then in October, we do have HMS, who's the parent company for Anybus and E1, will provide an update. So as always, stay tuned. We'll keep you informed of the topics as they're coming out. We mentioned Automation Fair there. So we've been, kind of reminding everyone or just notifying everyone that Automation Fair this year is going to be in Boston. It's going to be the week of November 6th. It's going to be a longer session than normally. Normally it's 2 days, so Wednesday and Thursday for the expo. This year it'll run from Monday through Thursday. The expo will still be just 2 days, the Wednesday and Thursday, but the Monday and Tuesday will offer more sessions, the ability to take advanced training, keynotes, as well as some industry forums during those days. So we're in July. November is going to sneak up on us. So we'll keep talking about Automation Fair over the next few weeks and months as well. And finally, to get to our actual presentation today, we have our two specialists that will help us out. Todd Abshire, component specialist with the Reynolds Company, and Mike Olette, our drive specialist as well. So we will turn it over to, I believe, Mike first. Stop my sharing and let Mike take over.
All right. Hello, everyone. Hey, my name is Michael Olette. I'm with the Reynolds Company. And obviously, I need some help technically on the Zoom. But I'm here to present the PowerFlex drives. The PowerFlex medium voltage is also included in that. I won't spend much time on that, but we have the 753, 755 series. The main thing is that we're gonna touch on today is the 755 TS and how it also works with the 755T in conjunction with that. You can program these with Connected Components Workbench. All of our drives, Connected Components Workbench or the Studio 5000, and then using Logix 5000. So with that said, just to show that all of our drives are the PowerFlex 750 series. You can see the 753 series on the bottom, 755 on the top. They have 3 and 5 slots available for the IO. The 755 does not come with IO. It does come with an enable. So you will have an enable there, but if you want to add IO, you can do that through the IO slots on the cards, rather, optional cards, or you can do everything through Ethernet because it does have Ethernet as a standard single port. And then, so let's go on to the next. We won't spend much time on this. This is the 523 and 525. These are our smaller drives. they only go, the 523 has a little less IO, the 525 has some more IO, which also includes Ethernet on that as well. And then this is the whole family here, only goes up to 30 horsepower. Like I said, I won't spend much time on this, but you can see the little module up front there, the programming port and control port is the same size, so it's universal on all the frame sizes. And then we get into the 755. This is the main reason we're here today. 755 TS has some advanced functionality over our 753 and the standard 755. 755, the standard 755 is also starting to use some of those similar features, but the TS is slightly different. The TS, as you can see from if you know our drives, the 755 TS is slightly different in color as far as the look, but it's all the same functionality, same programming. There's some additional features, obviously, security, safety, and some other things in that, and also the smart functionality. 755 TS right now is only available up to 400 horsepower. They are advancing that, moving into larger platforms. It does also have a built-in gigaport Ethernet, which is different from the 755. 755 just has a single port. And then also has what they call a T-Link, which is a fiber optic drive-to-drive communication port. For if you're actually going to be starting to use these in like SIP motion, if you're using SIP motion or you're using a motion type application, you can do that as well at high rates of speed using that T-Link. And that does also involve getting, there's another little power supply and stuff for that. Nothing really costly, but so there's a T-Link high speed communication port on that. This is kind of the whole family of the 755, 753s. As you can see how it fits into the family here. The 755 TS is a 6-pulse drive, so it's similar to the 753 and 755. It is a 6-pulse. If you look over to the right there, the 755 TL, TR, TM, those are active front end drives. So the TR is a regenerative type of drive, and the TM is a common bus drive. That common bus drive can also be tied in with lower horsepower as well. It doesn't have to be all the same horsepower that it's on the common bus structure with. So just so you know that they don't have to be all the same horsepower, same amperage rating. But those TR, TL, TMs, those are active front end drives. So which would be comparable to like a 24 pulse drive, whereas I mentioned the 6 pulse earlier. This would be a little bit as far as the advanced functionality. As you can see, it's motor agnostic. You can use your induction style motors, you can use synchronous motors, and you can also use permanent magnet motors with the 755 TL drives, or TS drives, I'm sorry. They can be used with the TL too, but the TS drive. So it is motor agnostic. It does have some other, as far as disturbance rejection built into it. As you can see in the middle there, there's different parts built into the drive. Some of our competitors talk about like direct torque control. That's nothing more than like a sensorless vector or vector control. The same thing. It actually gets feedback information from the motor and then pushes it back into, actually does the math in the drive for certain characteristics of what it's seeing out of the motor, makes changes, and then tunes that. These are some of the additional things that are in the 755 and 755 TS TL drive. You have predictive maintenance. We also monitor like the fan life, there's other things as far as the having to do with the IGBT temperature. Those are pretty much given. But if you look at this, you can see the stuff over on the left that actually does the math as far as the IGBT voltage, IGBT temperature over time. There's some different algorithms that are in here. The switching frequency, and actually identifies the life of the IGBTs through the drive itself. So, there's some things you can do as far as predictive maintenance to stay ahead of any failures if you have a critical application that's actually doing. But you can see in the middle there where it talks about a cumulative damage. So that's just degradation of IGBTs due to higher switching frequencies or temperature or things like that. So you can see on the end there remaining life, hours, life percentage variable. That's the stuff you can get a bit out, actually display if you'd like, or get through any network you want to do a preventative or predictive maintenance. Some of the things with the 755 TS drives, there is a total force technology, which you see here, load observer and also adaptive tuning. They kind of work together. The load observer actually identifies the load, changes in the load, and automatically compensates for that. Again, you can see the where you start jumping into the adaptive tuning. This actually proactively tunes the drive on the fly. So say, for example, if you're having like a resonant issue with the motor or vibrational problems, it will try and tune those out. I mean, unless the motor's actually going into failure, then you can set some other parameters that will tell you that the drive or that the motor is having problems. You can set boundaries on that as far as a high and low threshold. But the adaptive tuning and the total force technology actually automatically, some call it AI, but it automatically will tune those resonant frequency or resonant issues out, or even in the load itself, will actually tune those out. This is kind of an example of it here. You see, in the Houston market, we don't have much of this, but say for example, if you've got conveyors or even pumps, maybe due to the process, something's affecting the flow of a pump, or you can see a swinging load here. If the load sees that it's swinging back and forth, that's usually due to the excel or decel of the drive. The drive can actually identify that. Again, these are programming features that are built in or that you can program in, but it'll actually identify that shifting load and adjust for that automatically on the fly as time goes by. Also, I know years ago there was always a bottles. They use bottles on a conveyor. That's a little more difficult to see a shifting load on that, but that's also some programming features that we can program out pretty easily with Excel and decel rates too. But that's the major functionality of that. If you look over to the right over here, you can actually see a little diagram that's showing like noise coming back from the motor, and that's got to do with variations in amperage and other draw that the drive is seeing at the motor. Some other things with the 755 and 755 TS and TL. We've got you look down on the bottom here, it's got the XT option. And if you look at the drives over on the left, with regard to the TS family, you can see the furthest one to the left is actually a standard coated board. Doesn't have the XT option as far as the coating on the boards. But if you look at the other version here on the right, that's kind of an indication that it does have that XT corrosion resistance. I wasn't done with that slide, sorry about that. So the conformal coating, the actual furthest one to the left has your standard formal coating, whereas the one on the right is you start getting into the XT. Some of this actually was done through Rockwell has their own test facility, so they do their own test on this, and it's a 30-day exposure test, which is actually to the ASTM V845. 845. So it actually runs, I think it's like a 10-year test they run in 30 days, and they actually have a corrosive environment that they put that through to actually identify the long-term damage on a standard conformal coated board, or most of them have conformal coated boards out there, but to get to the XT certification for this V45. This is just an example. You've got, some of your dendrite growth, which is you see the discoloring on the boards, like on the upper left there. That dendrite growth, that's actually, those are like type growths that'll actually, I don't want to say eat through the board, but they're made to grow in a crystal type format, which will actually work its way in through other conformal coatings and stuff like that. And if you see over on the right, that would be an example of the XT with the corrosion, the additional XT protection on it. Similar with down on the bottom there. If you look, those are the actual contacts, and most say, well, how do you connect contacts? Well, we do know, throughout electronics, we have dielectric type substances that we can put on contacts. In this case, we do as well. So if you look over to the right there, that's just an example of, so you can have total water protection for like not only a salty environment, but a high chlorinated type environment or acidic environment, which is good down here in the oil and gas and chemical industries. So you can see that it's definitely beneficial to go with the XT option. This is just another example, but we do also have available you can get it other places too, with the dielectric grease. So, if you're buying the XT drive, you may want to consider protecting the contacts on those drives as well, using some sort of dielectric grease. Again, you can see the example there. These are examples of the available boards, and we do have all of these in the standard conformal coated as well. So if you look at the XT and the end of the part number, that's indicating that it does have that certification of protection that we were talking about earlier, additional protection. And so you can get these, because if you look down like to the 20-750 2262, those are just standard IO boards. And again, so we do have standard IO boards. We've got the safe torque off, safe speed boards down below at the bottom there, and also that T-Link board that I mentioned earlier for the peer-to-peer communications between drives, high speed. So that's just an example. You get over to the right there, you start looking, any boards that are in red will indicate that they are a safety type board. So like the bottom four there, the safe torque off, safe speed, those would be in red when you actually purchase them. CIP Security, the one thing with the 755T family, again, getting into the TS, TLs, we do offer CIP Security. It's, with some of the things going on today, risk of cyber attacks, different things like that. We can, even with drives, we can get down to communicating with the drive through Ethernet, where it's all, you have to use authentication. You can use different encryptions and stuff like that. So, so the drive is secure and allowed to function without any interference from outside. Some of the different boards we have, I had mentioned safety type products. Safe torque off is the furthest one to the left there. That actually just allows you to shut the drive, keep the drive running, but shut the IGBTs off to a secured level so you can actually work on the motor. Safe speed will allow you to go down. If you can't stop a process, you can actually drop the drive down to a safe speed. So it's no longer so it's reducing pressure or reducing something to keep the process actually flowing or moving. You start getting into the S3 and S4. You actually start getting into where you're able to get on the network and hardwire with the S3. The S4 is actually it's used with the guard logics. This device here, you see the little safety man there. This is actually Ethernet. You can connect up through Ethernet using a guard logics controller and actually control and keep the drive secure through that S4 option. That also does require, I might have mentioned it earlier, a small external 24-volt card as well. There's also some other cards as far as a power supply card that can be used in that. So if your main power were to go down, you could actually shut the drive down and keep everything running in a safe manner using some of these features. Not only the S4 card, but as well as the additional power supply card, which is a slot mountable power supply card. This is just another example as far as the functionality and what's available as far as those safety cards, the S4 option. You can actually start seeing where you can get into safe braking, safe limit speed, safe direction. So there's multiple things that can be done with that. This would all be configured. You can configure it through your Studio 5000, but using your Logix 5000 internal to that. And again, this is for the variable speed drives, 755 series, 755 TLTS. And it also will work in conjunction with our servo systems as well. So, but yeah, that's just kind of a rundown of that. This is just we're kind of working toward the end now, but these are some of the different, shows you that all of our drives in the 750 series, 753, all the way through the 755 TS, TLs, TRs, they all use the same IO cards, all the same HIM modules. Now, if you look in the front there, they also have all the same HIM modules. So they're all universal as far as doing different copycat functions. You can do that through the HIM module as well, not only through the software that I had mentioned at the beginning, but the communications and everything are all the same to our whole family. I think that's just important to note as we're kind of winding down here. This is one I always like to show. A lot of people have seen this, but this is just to show that we do have automatic device configuration. This is used with, as you can see on the left there at the top, like a Logix controller, then through like a switch of some sort. I don't know if the switch numbers are valid anymore, but anyway, this is an old slide. This just shows an example if you were to have a drive out in the field or out in the plant shut down, it actually fails at a certain time. You can actually, your people can go out on the floor without any technical knowledge or ability, without any additional programming required. Again, this all has to be, the program has to be saved within the Logix controller. And that's all obviously saved in the drive as well. So they were to install a new drive, and the drive doesn't have to be the same horsepower, but it does have to be the same frame size. So if you have a frame 1, say for example, in a 2 horsepower, and well, that's a bad example. Say anyway, if you have a different frame size, you would not be able to put that in, and obviously it'd take more time. So if you keep within the same frame size, the amperage can be higher, but you can just drop it into the slot there. The Logix controller automatically identifies, gives it its IP address, so it has the same IP address, flashes any kind of memory, and then also flashes the configuration and you're back up and running. So this is a very, very useful feature. Some people are using it, probably should be used more often, would save a lot of time from being down. Some other stuff, sorry, I'm going a little fast here, but some other stuff just to know, we do have other services as well as far as drives. Our drives, if you look at the frame, I know the first image had frame 8 and higher. Those can adapt directly, common bus directly to MCCs that you see over on the left. So we do have a common bus functionality there that we can integrate directly to MCC bus, and some other services that we offer too is in field services, pre-engineered drives and engineered drive services as well. So field services is a big one that should be utilized. And we do have people right in our facility here that can help coordinate that for you as well and with you. That's all I have today. I appreciate your time. I appreciate you bearing with me through my Zoom technical needs here, but you all have a good day. Thank you.
All right, well, thanks, Mike. My name is Todd Absher, and I am one of the component specialists here in Houston with the Reynolds Company. Today, I'm going to speak about our power supplies and how to build redundant and high available 24-volt DC power systems. Just a kind of a brief overview of the different portfolio of our power supplies. Starting on the left, we have what we call our basic. All the way over to our right is our superior. They each offer different things. The basic, even though it's called basic, it's still rated for a very long service life and provides a very robust solution at a competitive cost. So don't let the basic terminology confuse you. It's still a very good power supply. Just some of the different comparisons, some feature comparisons here. As you see on the left, the basic goes all the way up to 480 watts. And then all the way on the right, all the way up to 960 watts. We do have, in the middle, we do have our compact, so low power, anything in between 15 and 100 watts. Very compact, very small in size. Pretty essential, to have in real low power applications. We have DC to DC converters as well, and those, as well as our XLE Essential Series, offer a power boost of 120, and our XLS, our superior or Cadillac version, offers that power boost up to 150%. So let's get into more reliable 24-volt DC power systems. Some learning objectives for today: understanding the value of a true redundant system, how to build redundant systems using redundancy modules or power supplies with built-in redundancy, how to build high available power solutions using buffer modules or UPS with batteries or battery-less. And then to understand how redundancy and buffer modules and everything we talk about contribute to a reliable, high available system. So what is a problem when you have an unreliable DC system? Problem one, high voltage spike occurs, causing a failure of a power supply. This leaves the customer unable to supply voltage to their loads, ultimately shutting down one or more lines. By the time maintenance was able to safely repair, customer suffered several hours of downtime. Problem two could be something like a customer regularly experiencing voltage dips due to something like a motor starting up. This causes critical production line to shut down. Just one downtime incident has cost them over $250,000. It often takes time to restart these lines, increasing that production time. 98% of organizations say 1 hour of downtime costs them over $100,000. 81% of organizations say that 1 hour of downtime costs them over $300,000. And 33% of those organizations indicated that 1 hour of downtime costs between $1 and $5 million. So how can we create a high available, reliable system? Well, we can use redundancy to survive if the actual power supply device fails, or we can use buffer modules and UPS products to bridge DC power quality events. So think like that motor starting up. What is redundancy, and why do we need redundancy in our system? In a redundant power supply system, 2 or more power supplies are wired in parallel to increase reliability and availability of the DC voltage. You have, the second power supply as a backup, just in case one power supply fails. So you'll typically see this as like a 1+1 or an N+1 type of system, and we'll spend further time in upcoming slides on what that means. What are the benefits of redundancy? So is a redundant system necessary? Well, you would need to ask yourself a couple of questions. What are the expectations if a power supply fails? Do you need your line to keep going, or can you take on that loss? Are there any ramifications if a line is down, money, equipment failures, and is the power supply being used in a critical system? If yes is the answer to any of these questions, then we need to discuss getting you a redundant system. So problem 1, a high voltage spike occurs, causing failure of a power supply, leaving the customer unable to supply voltage to their loads and shutting down 1 or more lines. So the solution here would be to incorporate a redundant system so that when the power supply fails, we have a backup that can supply the full power or the current. So the benefits of this, obviously, we're going to prevent our unplanned downtime, protect critical components, create a fault-tolerant system, signal in case of a power supply fail, so you can kind of have a fail-safe. And there's a new feature on some of our power supplies that we'll talk about later that allows them to be hot swapped, which is pretty cool. So we can go in without any interruption. So now that we might know that we need a redundant system, how do we build them? Why can't I just put 2 power supplies in parallel and maintain redundancy? Well, if there's a short circuit at one of the power supplies, because they're in parallel, there's a short circuit at the other power supply. So now you've lost 2 of your power supplies. So they have to be decoupled. And we do that with a redundancy module. So like I said, to solve that, you put in the redundancy module that decouples the load from the power supplies. But we also have another option on the right, is we have redundant power supplies. So there's power supplies that have that capability built into them. So same system, 2 different methods of doing it, but achieves the same thing. So forms of redundancy, we talked about the 1+1 or the N+1. Basically, all that means is N is the number of power supplies needed for the required current without redundancy. And then N+1 would be that additional power supply required to build in the redundant. You could have multiple levels of resiliency. So you could have an N+2, an N+3, and so on. So 1+1 redundant system using redundancy modules. So in this example, we're looking at a 10 amp system. 1 extra power supply must be installed in order to deliver the required current in case 1 power supply in the system fails. In the system on the left, you see we have 2 10 amp power supplies. Our entire system could run on one of these, but the second is delivered the required current if the other does fail. So that's our 1+1. On the right, you'll see it's the same 10 amp system. It's basically the same setup. What this is showing is that some of our power supplies and some of our redundancy modules offer different features. So when you're going through and you're making your choices, look at the different features that they offer. Some power supplies offer the DCOK output, and some do not. Some of our redundancy modules offer that same functionality and some do not. So, you know, if your power supply offers the DCOK, you don't necessarily need it in your redundancy module. If your power supply does not offer it, that's a functionality that you could pick up in your redundancy module. Our redundancy modules can cross families. You don't have to stick with the same family. I know they have it here in the picture where XLE is used across an XLS, but you could use XLE with an XLS, or you could even use the XLB. The main thing to keep intact is just to make sure that you're getting all of the functionality that you need. So these are some of the options that we offer for our power supplies that do have the built-in redundancy. These power supplies, they do come with two different connection terminal options to get the built-in redundancy. In the part number, if you see an L, that is for spring clamp terminals, and a Z would be for plug connector terminals. The plug connector terminals are the ones that are hot swappable that I mentioned earlier. So keep that in mind. And then C, if you see a C, that's conformally coated. So we do offer some power supplies that do have some conformal coating. And then the D is an extra DC output for higher DC voltages. So building a redundant system using built-in redundancy would have numerous advantages. Obviously, you know, you can just look at the picture and see that there's three components for our system with the redundancy module, and only two. So right off the bat, you're saving the entire price of one component. But you're also saving around 40 millimeters of space. You know, and on one panel, maybe 40 millimeters of space, not that big a deal. But if you're doing hundreds of panels, you know, that's significant space savings and significant component savings as well. So just something to keep in mind. So far, we've really only discussed the N+1 or the 1+1. So now let's kind of take a look at the N+1. You know, N, like I said, is just the number of power supplies ordinarily needed to operate the system. So let's take a look at this example. Our customer has a requirement of a 30 amp system that needs to be high available. Our ordinary system would require 3 10 amp power supplies equaling 30 amps. Therefore, our N would be 3. But we need one extra power supply in case of failure. So that's the +1. So this system would be a 3+1 redundant power supply system. This system would generate 40 amps total, but only 30 is going to be utilized. And the cool thing about when you do this is that the load is shared across all power supplies, which increases the life of all of them. So get some extra bang for your buck. So we can also build our N+1 with our built-in redundant power supplies. So let's take a look at this. It's the same system, same 30 amp system, but we just need our 4 power supplies with the built-in redundancy to get our 3+1. So 3 would be normally required to operate our 30 amp system plus the 1 for our redundant. If you take a look at both, you can see that the previous or the redundancy module system required 6 units, and the built-in system only required 4. We do offer our redundancy modules with dual channel and single channel. Not, the only real benefit of that the single channel has, that the dual channel has, is that they're also hot swappable. So if that's important and you can get away with one channel, then that's a good feature. Just a quick checklist of things to remember when you are building a redundant system. Things like selecting the appropriate gauge wire. You set your power supplies to the parallel option mode. And this is available online if you need it, but just kind of an easy checklist to run through. So now that we've discussed redundancy, let's talk a little bit about high available systems. So here we'll discuss our buffer modules, DC UPSs, and how they help provide reliable, consistent power systems to us. So why do you need them? Power quality events such as voltage transients, noise, sags, can impact the availability of our system and prevent us from being able to provide voltage to the load. Some methods to build high available systems would be buffer modules and UPS products. So on the left, you see our buffer module providing milliseconds to seconds. Our DC UPS, EDLC, which is electrolytic dual layer capacitor. So they provide seconds to minutes, and then our longest runtime minutes to hours, which is our DC UPS with the battery. So like I said, statistically, 80% of main power failures are interruptions in voltage that lasts less than 200 milliseconds. So short failures, they're not going to matter for non-sensitive loads like your light bulbs or anything like that, but they can cause electronic equipment to drop out completely. Think DC coils of a contactor, drives, safety relays, and even controller inputs. So really quick drops in your power can cause significant damage or downtime. So buffer times do vary. They vary from milliseconds to seconds. It depends on the load with these. Our 24 and our 48, they can provide load currents fully rated up to 20 amps with a minimum buffer time of 200 milliseconds. And that time can get longer if it's lower load currents. Our EDLC Battery-Less DC UPS. These are for applications that require seconds to minutes of runtime. They have infinite charge discharge cycles, so they're really good in applications that you expect to drop out and have to recharge a lot. But these are also batteryless, which means that they're going to be really good in remote situations as well, because there's not going to be any maintenance on them. You don't have to go out and replace your batteries. You don't have to worry about switching out batteries or worry about if your battery has enough charge. These are good for, I think they say, about 10 years before you really have to do anything. So it's really, really a plug and play and kind of set and forget kind of solution. These are just the part numbers that they would be showing some different specs. And then you have your traditional DC UPS with batteries. These are going to provide you with the largest amount of backup runtime, 10 amp and 20 amp rated current, with also an additional 50% power reserve. In the picture, you see that there's that first part number on the left. That is actually a configured part that Rockwell offers. So it's the UPS plus the battery will come configured for you already ready to go. But you can also get them just the UPS, and then you can buy the battery separate. So, depending on what you need, you can kind of tailor that. Let's say you're not going to commission your UPS for a while. You don't want to get the UPS with the battery sitting there and just kind of, losing its charge while you're waiting to commission it. So you can just get the UPS, get it ready to go, and then get your battery separate, plug it in right when you're ready to commission, and then you know that your battery is going to be the most fresh. Here's just an example of the different part numbers that you would notice if you're going through trying to spec this out. The second one is the controller, the charger, and the battery together. It's going to have that C on the end. Different battery options based on what you need. So when to use buffer modules. Applications requiring milliseconds to seconds of runtime, high inductive load startups. So that, that big motor that you're starting up that causes $250,000 of downtime. You add a buffer module there, and get rid of that. You can use your battery-less DPS for remote applications, as I mentioned, applications with high numbers of charge and discharge cycles. And these are going to provide your seconds to minutes. And then your battery models, when you need longer times, minutes to hours. Also where remote monitoring and diagnostics would be desired. You do have the battery to worry about, but you can, to monitor these back with the DCOK, you can monitor these back with your to your PLC. So just something to think about. And just a list of materials we have available, some flyers, some specifications that you can go through and read, and hopefully design a better power system for your needs. Thank you for your time. We appreciate all of you coming.